Let's just look at the three-dimensional coordinate system. For our textbook, positive x is to the right, positive y is up, and positive z is forward. Here's an example of a vector that's coming to that front right quadrant. So it has something in the positive x, positive y, and positive z direction. In 2 dimensions, we broke vectors into their x and y components. Here's that x component for the vector in 3 dimensions. And here's the z component going in the positive z direction. And here is the y component coming up in the positive y direction. Start at the tail, walk to the front. We'll break the vector into components using triangles. First, notice the right triangles on the ground. This will give us our x and z components, those triangles on the ground there. To find the y component of our vector, we're going to create another triangle that's standing straight up. Now this is another right-hand triangle, and the side that's going straight up, that's our y component. And you can break it into, see it as triangles or as rectangles, so whichever way you want to walk around these sides, we just need to know the side in the x direction, in the z direction, and in the y direction. Let's walk around this one more time from the front. Okay, so you see where your positive axes are. Our z component is coming forward, and then our x component is going to the right. And it doesn't matter if you grab the front or the back of that rectangle. Either one is the same length. And y is going straight up. And these are all right-handed triangles that you're looking at here. I'm also going to label this side H. Now this is the side that connects the 2 triangles. The base of the triangle standing up is the hypotenuse of the triangle on the ground. Let me just rotate around this system one more time slowly for you so you can get a good look at the rectangles and triangles involved, because once you can see this for one of these vectors, you can create the same rectangles and triangles for all of the vectors involved. So again, there's just a rectangle straight up that has a vector corner to corner in it, and then there's a rectangle on the ground that is created by 2 right triangles. Okay, so let's put a few numbers on this thing just so you can see a triangle. And I don't want you to memorize that Fy is always sine of an angle or cosine of an angle. Look for the right triangles, and it's going to be different what angles they give you from problem to problem. So you'll just have to figure out which side is sine, which side is cosine, where's your hypotenuse, and then map the top triangle onto the ground triangle through that hypotenuse, and just walk your way around the right triangle. Once you see which is the 90-degree angle and which is the hypotenuse, it's not that hard to walk around those 2 triangles.